This is a continuation of a screencast to help you understand the working of the assignment for the Bayes theorem week, which is week 1 in this year, which is 2011. Remember that we start with a hypothetical group of 1,000 people. And then we decide how many of those people have the illness using the base rate. In this case, the base rate is 94%. And so that means that of these 1,000 people, how many of them have the disease? Well, that would be 940. And then how many of them do not have the disease? The remainder, which is 60, because 1,000 minus 940 is 60. Now we need to figure out how many of these 940 test positive, which would be the correct answer, and how many of these 60 test negative, which would be the correct answer. And each of these erroneous answers can be calculated then by subtraction from the number up here. You'll remember that you take the sensitivity and multiply it by the number of people with disease in order to get this number here. And remember also that we call this number A, B, C, and D for any time we might need to use algebra. The sensitivity in this case is 0.63. And 0.63 times 940 turns out to be 592.2 actually. 592.2. It's a bother to write that extra part, but anyway. The specificity is 0.10, or 10%. You need to learn to go back and forth between things given as decimals like 0.10 and 10%. If that's troublesome for you, it's something to get used to because they can be given in either way in articles. All right, so 10% of 60 is 10, so that number goes here. We can get C by subtraction. 60 minus 10 is 50. And we can get B by subtraction, 940 minus 592.2, and I used a calculator for this, but it's 347.8. All right, now the positive predictive value. Now remember what that is. The positive predictive value is the probability, if you test positive, so that's these people and these people, that you truly have the disease, which is these people. So we have to take the probability of 592.2 plus 50 as the denominator. And the numerator is the people who truly have the disease, and that's 592.2. And so if you do the calculation, and remember that you can do this by a formula if you want to, A over A plus C. Then when you grind through the calculation, what you get is 91.6%. So if you test positive, there is a 91%, 92% chance that you have the disease. Negative predictive value. Now remember what that means. Think about the definition for a second. What is the probability if you test negative? That's those two groups, that you don't have the disease. So what goes in the denominator? The number of people in these two groups. 347.8 plus 10 is easily seen to be 357.8. 357.8. 7.8. I hope you can read that. And in the numerator here, we would then put, guess what? 10. 10 people are truly negative, people who don't have the disease and test negative, and that number turns out to be 1.7%. And then if you like the formula, you'll remember that is D over B plus D. All right, so this is, that's a bad D over B plus D. It's hard to write with this thick brush here, but anyway, so let's just scratch that out. So notice that if you test negative, there's only a 1.7% chance that you're free of that disease. In other words, there's a 98.3% chance that you have the disease even if you test negative. Isn't that interesting? So if you test negative in this test, there's a higher chance that you have the disease than if you test positive. Now what does that mean about the test? Well, the test is not working very well, or perhaps it's not keyed correctly in the right direction. It would actually do a little bit better as a test if you reversed the keying on it and called high scores low scores and vice versa.